everyone, in today's lesson we're going to review our four main exponent rules. The first rule is when we multiply powers with the same base. So what this looks like in symbol form, if we have x to the a power times x to the b power, that will simply become x to the a plus b. So if we wanted to do an example with numbers, we would say, I don't know, x squared times x to the fifth. We add them and we get x to the seventh. Now remember, if there are coefficients in front, we actually would multiply them. So if we had, let's say, 3 and 7, 3 times 7 would be 21. So this rule that you see right here are just for the variables that have the same powers. Okay, let's do an example with dividing. So when we divide powers with the same base, we're going to keep the base and then subtract the powers. So what does it look like as far as a definition? Would be x to the a divided by x to the b would be x to the a minus b. And again, if we wanted to do an example, we could say x to the 10th divided by x to the 4th, and that will give us x to the 6th. We keep the base, subtract the powers. Now, if we had a coefficient in front, we would simply divide them. So if we had 2 on the top and 4 on the bottom, we would divide. But be careful here, 2 divided by 4 is not 2, it's actually 1/2. The smaller number is on top, therefore it would be 1/2. All right, the next rule is raising a power to a power. So when we do that, we keep the base and we multiply the powers. So what does that look like in symbol form? That would actually be x to the a to the b power would be x to the a times b, x to the ab. So again, if we wanted to do an example, we could say x to the 3rd to the 6th power. That would be x to the 18th. And if we put a coefficient in here, let's say 2, we would have to do 2 to the 6th power as well. So 2 to the 6th. It's not actually going to be 2 times 6, but 2 to the 6th, which is 64. And then last but not least are negative exponents. When we have a negative exponent, we bring the powers to the numerator or the denominator to make positive or negative. So the rule is x to the a is equal to 1 over x to the negative a, or x to the negative a is equal to 1 over x to the a. So what I did for the equivalence, it was negative in the denominator, so we bring it up to the numerator to be positive. If it's negative in the numerator, we bring it to the denominator to be positive. So let's just do an example and see how we do with these. All right, so first things first, we want to distribute the power first and use order of operations, which is PEMDAS. So we're going to take every piece that's inside and raise it to the second power. So -4 squared and then q3 squared. And that will give us, well, -4 squared is a positive 16. Be careful if you use the calculator to put it in with parentheses, otherwise it would give you the wrong answer. When I raise a power to a power here, I multiply, so that would give me q to the 6th. And then the denominator stays the same as -2 q to the 9th. So we're going to take our numbers on the outside. I'll even highlight it so you can see. We're going to take these numbers and we're going to divide them. That number is going to be -8. And then we have the q of the base. We're going to keep that base. And we're going to subtract the powers. So 6 minus 9 is -3. Now we want to write this with positive exponents. So we actually have to take this negative exponent that we see here, and we have to bring it downstairs. And that's how it will become positive. So it's -8 all over q to the +3 now. And that is your final answer. Now, just a couple things. This coefficient, -8, it is negative, but that doesn't mean we bring the negative downstairs. The only thing that goes downstairs is the negative exponent, not negative coefficient. All right, that was a quick review of exponents. Why don't you guys try the second example here and then hit resume when you're ready for the answer. All right, this is what I got. So just a couple things to keep in mind. 1 over 243 is not the same thing as negative 243. So 3 to the negative 5 is actually this fraction, not negative of that. When I subtract those, I got negative 3, so I put that here in the numerator, and then I moved it downstairs. And I divided these two coefficients and got 486. So that stays on top, and then b to the third joins the v to the 15 that was already on the bottom. Now this one I know is a little bit more challenging, so if you have questions on it, we can absolutely go over it in class tomorrow. All right, the second thing I'd like to review today are that fractional exponents can be expressed as radicals. You should have seen this in Algebra 2 and in pre-calc, but we will be using it a lot in this course as well. So if I have x to the, we'll say, a over b, some fraction, that is equivalent to b root x to the a power. Now, you may have heard power over root. So I like to use this analogy here. Here's an example of a tree with roots on the bottom. So if you consider this the roots, right? Those are your roots on the bottom. That'll help you determine what goes where. So in other words, we can say that this is x to the power over root is equal to the square root, whatever is on the bottom goes there, of x to whatever power. So that's going to be your general rule of thumb. So power, another way to remember the powers go on top. Think of those power lines that are in the streets, right? The power lines that are above your house. Power lines, I know this is an awful drawing, but power lines are on top, roots are on the bottom if this is your fraction, okay? So let's use that to answer the first question. First question says, express your answer as an exponential expression. So if this is my root, the 5, and the 3 is my power, this is simply going to be x to the power, which is 3, over root, which is 5. Now, example number 2 is a little bit more challenging because we have to do some work first. So first, we're actually going to need to simplify what's in here first. So we're going to leave it as the 20th root of z to the 8 minus negative 7, right? Because we're dividing, we subtract the exponents. So 8 minus a negative 7 is the same thing. 8 minus negative 7 is the same thing as saying 8 plus 7, which is 15. So then we have our power and our root. So our answer is going to be x to the power, which is 15, over root, which is 20. Now, technically, we can simplify that fraction, 15 over 20. We can divide the top by 2 and the bottom by 2. So then our final answer is, 5. So then our final answer will be 3 over 4. 15 divided by 5 is 3, and 20 divided by 5 is 4. And that would be our final answer. All right, how about the reverse way? What if I want to express this as a radical expression? Well, the first issue that I see in this first example is that I have a negative exponent. We need to first make that exponent positive. And we know that we can make the exponent positive by taking that negative exponent only, so just this piece, not the 6, and bring it downstairs, so x to the 1/5. So now that our exponent is positive, we now know that we could say that 5 is my root and 1 is my power. So my final answer is 6 over the 5th root of x to the 1st. And that's my radical expression. So anytime you're doing this, the first thing, you must have positive exponents. All right? So in order to do the second problem, we need to do some work first. So the first thing maybe we could do is multiply those by adding the powers. So -1 plus 2 is 1. So we have 1 over y to the 3/4 power. And when we have a power on the outside of a fraction, we have to distribute to the top and the bottom. So we have 1 to the 3/4 over y to the 3/4. Now the numerator, it's actually easier than you think. 1 to any power, whether it's a fraction or not, is always going to be 1. And then the denominator, we're going to do the same thing as before. Here is my root, and here is my power. So it's the 4th root of y to the 3rd. And this is my final answer. All right, that's it for today. If you guys have any questions, now is a good time to jot them down and ask us in class tomorrow. All right, have a good night.